Hypothalamus Artificial Intelligence, HY, presence. The HY, IBM, TD, SYNNEX and Peer-to-Peer Global Alliance, and the HY, GAMS Alliance aim to develop mathematical models and offer professional services based on artificial intelligence for decision-making for enterprise-wide optimization systems, EWOS. HY integrates its OpTex, optimization expert system, with IBM technologies such as WatsonX, Decision Optimization and Plex Optimization Studio and with GAMS General Algebraic Modeling Systems. Below are the products and services offered to the electricity sector. The conference is called Here and Now on Artificial Intelligence, and the State of the Art of Optimization in the Electricity Sector. Here and Now of Artificial Intelligence. HY and its partners understand that professionals face increasingly complex challenges. Mathematical modeling as a service ensures more reliable and efficient operations in the electricity and gas sectors, while integrating renewable energy intelligently. This technology is growing rapidly, as traditional tools do not respond to the scale, speed, and complexity of modern decision-making. Add to this the fragmentation of data, the pressure for greater transparency in planning, and the high cost of suboptimal decisions. It's clear, incremental improvements aren't enough. What's needed is structural change. Imagine a system capable of orchestrating all your energy assets with a unified decision engine, from automatic dispatch modeling to energy trading and risk management, including emissions, maintenance constraints, all in real time. This allows your teams to anticipate, simulate, and optimize every operational decision, turning uncertainty modeling into a strategic advantage. State of the art of optimization. The accelerated evolution of artificial intelligence is supported by the growth, also accelerated, of computing. This has enabled the development of a robust library of algorithms, application development, and successful use cases in large global enterprises. With applications in general industry, energy, oil, gas, mining, agriculture, transportation, finance, education, regional planning, and others. This growth is supported by a new look at optimization, which is totally different from what most executives and managers knew in the past. This has allowed the creation of new concepts such as the artificial brain, which is the widespread use of multi-problem mathematical models in parallel, in real time. This approach is totally different from the past, in which mathematical models were reduced to solving an individual problem, and not to an integrated system oriented towards the holistic optimization of companies. Hypothalamus Artificial Intelligence. Presence. OpTex, Optimization Expert System. The optimization technology that allows you to assemble multi-problem mathematical models like a Lego game, using structured mathematical modeling. Can you imagine how? The optimization expert system makes it easy to making high-complexity large-scale mathematical models without programming. The foundations of OpTex database algebraic languages consider the algebra as a standard, to express the relationships between the different parts that make up a mathematical problem. It can be said that there is only a reduced way to write an algebraic equation. This is independent of the symbols that are used to represent the physical or logical relations. Additionally, if two algebraic formulas are joined, a new algebraic equation is obtained that retains the same structural characteristics of the original equations. This transitivity law may be extended to mathematical programming, MP, which in essence is a collection of algebraic elements. Then it is possible to join two MP problems to obtain a new MP problem. It is also possible to divide an MP problem into two MP problems. The multiple models are assembled like a Lego game, which can have as many groups of tiles as there are models. OpTex opens a new path for thinking about mathematical modeling. Joint problems is much easier than writing equations. That's the future of mathematical modeling, which has been used for 35 years by OpTex, the optimization expert system. Don't write equations, every mathematical modeler's dream. Do you wonder of how to make high-complexity large-scale artificial brains, without programming? The best way to make software is having to do it, is the goal of OpTex. The HY approach is aimed at developing cognitive robots, that eliminate the tasks of computer programming, since the robot takes care of this process. This enhances the mathematical modeling capacity of the professionals. The traditional process of mathematical modeling implies that programmers, usually mathematical modelers or data scientists, must make great efforts to implement complex optimization models. The expert system is Optex's AI approach. HY is not aware of a similar approach to mathematical modeling, and it has been used by HY since 1990. The Optex software generation involves accessing the AI expert system and processing its content to generate the software on the selected optimization platform. The Optex multi-problem model approach gives rise to the artificial hypothalamus. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus of the company is obtained. This is how the human brain faces reality. Multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by Optex, using the models that traditionally make up a decision support system. The concept of artificial hypothalamus can be applied to solve real-life problems from multiple points of view. In the diagram, the artificial hypothalamus coordinates models corresponding to the multiple problems faced by a company, organized from the point of view of its administrative functions. Another point of view is the spatial distribution of the problem. In this case, an artificial hypothalamus is presented for an agro-industrial company that has multiple facilities, farms, concentrated food factory, meat products factory, and stores in the food market. The entire relationship between the optimization models is stored in the expert system. Quantum computing and artificial intelligence are two transformative technologies that, when combined, create quantum AI. This integration leverages the unique properties of quantum mechanics, such as superposition and entanglement, to enhance AI's capabilities to solve complex problems, optimize processes, and analyze massive datasets. Quantum computing operates on qubits, which can represent multiple states simultaneously, unlike classical bits that are binary, 0 or 1. This allows quantum computers to perform calculations at exponentially faster speeds, making them ideal for AI tasks such as machine learning, optimization, and data analysis. Optex Quantum AI is the version of Optex that produces algorithms that can be solved on quantum computers. It inherits all the AI features of Optex Optimization Expert System. We can affirm that Optex Quantum AI is the state-of-the-art of optimization. The reasons are: generative artificial intelligence to produce the codes of the algorithms without programmers, and access to the world's fastest algorithms. Quantum computing, unlike classical computing, is a relatively recent development. Its origins date back to the late 1970s, when it first appeared in science fiction. In 1981, Nobel laureate Richard Feynman was credited with pioneering the concept of the quantum computer. His rule of thumb was, if you can't explain it simply, you don't understand it enough. In 1985, David Deutsch formalized the concept of a quantum computer, marking an important milestone in the field of quantum computing. Chaining Optex to super server in the cloud. In this case, the current one in the industrial environment, the programs are installed on a super server and solve the problem. The generation of quantum software in Optex involves accessing the expert system to generate the software into a computer code according to the quantum computer, like IBM Qiskit. Chaining Optex to quantum servers in the cloud. This is the new approach to the industrial environment in a short time. The structure of the Optex expert system supports the new functions required for the new interface. HY is working in this direction considering the studies carried out for the implementation of quantum AI. This involves the generation of new computational languages and their connection with quantum algorithms. Optex should be installed on any computer running MS-DOS where the programs to be sent to the quantum computer are generated. IBM Quantum Platform provides access to quantum computers, documentation, and learning resources in one place. IBM Quantum is building a large-scale, fault-tolerant quantum computer. In 2029, IBM will deliver a system that accurately runs 100 million gates on 200 logical qubits, unlocking the first viable path to realizing the full power of quantum computing. The first quantum advantage claims are emerging, but how will we know when it has arrived? Researchers from IBM and quantum startup Pascal explore this and other questions. Just recently, researchers at the startup Kipu Quantum claimed a runtime quantum advantage, where their quantum algorithm ran faster than specific-purpose classical solvers for dense, higher-order unconstrained binary (HUBO) optimization problems. They identified instances that were challenging for methods like Plex and simulated annealing and found that running their BFDCQO quantum algorithm on ever-improving quantum hardware reported faster approximate solutions. The results are impressive. BFDCQO can consistently achieve comparable quality and the yielded solutions for the tested instances up to 80 times faster than Plex, or up to 12 times faster than SA. They expect their runtimes to be soon orders of magnitude faster as hardware continues to advance. The results are inconclusive, indicating that the development of quantum optimization algorithms is under investigation. For this reason, HY carefully follows what is happening, to select the best alternative. Optex gives stakeholders an advantage by facilitating the availability of many real-life models applied with traditional methods, which can easily be used to conduct research and develop proofs of concept with quantum computers. Chaining Optex to the quantum algorithm. HY's approach to quantum AI is based on two steps. The formulation of the models is based on Optex, optimization expert system, which generates the programs without the need to perform programmer activities. The algorithm already coded for execution is sent to the quantum computer. Optex generates the algorithm in an appropriate computer language, according to the availability on the quantum computer. Optex Optimization Mathematical Model Store. All models made by HY are stored using Optex, optimization expert system, producing a warehouse of proven mathematical models that provides a valuable resource for the creation of new models. Optex resembles object-oriented programming, where programmers reuse components that already work, which not only saves time, but increases the reliability of the developed models, which operate perfectly. In this way, Optex currently manages a warehouse of hundreds of models, created since 1978, and stored at Optex since 1990. Optex Optimization Mathematical Model Store prevents users of working models from having to perform a recoding process to have access to quantum computers. When Optex Quantum AI is ready, all current models implemented in Optex will be available for on-the-go use. Here and now of artificial intelligence in the electricity sector. HY has more than 50 years of experience solving problems for companies in the energy sector using models based on decision-making artificial intelligence. The image, produced by IBM, presents opportunities for optimization along the electricity supply chain. The models and services offered by HY are aimed at supporting the decisions of companies and organizations in the electricity sector, either through simple mathematical models, traditional decision support systems, and/or business artificial brains. These include optimization of dispatch of electricity and gas systems and markets, energy trading and risk management, energy efficiency optimization, evaluation of energy projects, smart grid optimization, regulatory affairs modeling, electrical asset maintenance, and software factory. The image presents what could be the decision support system of a generator, which follows the principles of enterprise-wide optimization, whose architecture is conceived as composed of multiple models of different types. Predictive artificial intelligence, advanced probabilistic models, synthetic generation of hydroclimatic variables, state estimation with the dual Kalman filter, and ARIMA-GARCH statistical models of spot prices. Interconnected system simulation model. Regulated economic dispatch. Optimization models. Robust supply chain design. Optimization of asset maintenance. ETRM, energy trading and risk management, and economic dispatch and unit commitment. Optimization of dispatch of electricity and gas systems and markets. HY Power is a decision support system that has been developed to support the decision-making processes of agents participating in the electricity and/or natural gas markets. HY Power is composed of a set of optimization models that describe the supply/demand process of electricity and natural gas. From this point of view, It determines the partial equilibrium point of the electricity and gas markets under conditions of economic efficiency. To develop, implement and maintain high power, is used OPTEX, Optimization Expert System, that it is the artificial intelligence created by HI that makes enterprise-wide optimization systems for the entire company. High power is built following the principles of structured mathematical modeling, which are specific to OPTEX. Under this conception, software is built by means of layers of equations, which are integrated to build the models, which are part of a decision support system. In the case of high power, it is an economic dispatch model, typical of the electricity sector. The diagram shows 8 of the many models available at high power. Any of the models can be run in their deterministic or stochastic version, making use of asynchronous parallel optimization. High power is built following the principles of structured mathematical modeling, which are specific to OPTEX. Under this conception, software is built by means of layers of equations, which are integrated to build the models, which are part of a decision support system. In the case of high power, it is an economic dispatch model, typical of the electricity sector. The diagram shows 8 of the many models available at high power. Any of the models can be run in their deterministic or stochastic version, making use of asynchronous parallel optimization. A well-known use of the high power is the ModPlan model. Implemented for CO's SYNNEX, the ISO of design, used it for the planning of the expansion of the transmission system of Peru. ModPlan has been operational since 2014. Energy trading and risk management. Energy trading and risk management. According to Peter Bernstein, in his book, Against the Gods, The Remarkable Story of Risk. The revolutionary idea that defines the boundary between modern times and the past is mastery of risk management, the notion that the future is more than a whim of the gods and that men and women are not passive before nature. The essence of risk management lies in maximizing the areas where we have some control over the outcome, while minimizing the areas over which we have no control and the link between cause and effect is unknown. Energy trading and risk management, ETRM, corresponds to a function in companies that carry out energy trading activities, which inevitably require scientific management of financial risks. High ETRM corresponds to a set of mathematical models intended to support the decisions of the different agents involved in energy supply chains. It is made up of the following models: long-term stochastic optimization of energy trading, integrated electricity gas dispatch, intended for the determination of spot prices in an electricity and gas market, using technical economic models that simulate the electricity market, and/or the gas market, and statistical projection of spot prices using Armax-Garch methodologies taking as references historical series of the spot price. ETMR mathematical models include financial risk coverage, multi-criteria optimization, and value at risk, VAR, analysis. The main result is the expected revenue, or cost, versus risk curve. As shown in the figure. Energy efficiency optimization. High EEO, energy efficiency optimization, is made up of multiple mathematical models which together support solutions in different aspects of energy efficiency in industries. The objective is to minimize the costs of energy consumption, or the energy used, and to control emissions, or any other pollutant. The solutions are grouped into 2 groups according to the type of industry, for example. Heavy industry, which includes the following industries: chemical, petrochemical, steel mills, steel, mining, metallurgy, and large manufacturing industries. Oil sector, production, refining and/or transportation of crude oil and refined products, and buildings, such as shopping malls, offices, residential complexes, universities, etc. In the industrial environment, mathematical models of energy efficiency include modeling of industrial processes, which are the ones that generate energy demand, and models of energy supply, mainly electricity and fossil fuels. The diagram presents an example of how energy of different types is consumed throughout the cement production chain. Energy project evaluation. The energy market is changing rapidly. When evaluating a project, many aspects, or alternatives, must be considered, for example. Smart grids plus distributed generation plus new unconventional sources plus supply of thermal fuels plus interconnections plus smart equipment plus energy storage plus demand response plus. Hydroclimatic risk is decisive in the electricity market, which is greater if exposure to the risk of fuel prices is considered. The legal and regulatory framework, which offers new possibilities for self-generation, cogeneration and its marketing, is changing, which generates regulatory risk. Since the end of the last century, HY's mathematical models have been used to evaluate multiple energy projects, which has become a methodical and science-based process that guarantees the investor an accurate assessment of the economic value of the project, in terms of the revenue distribution function and its volatility. The process to follow is: high power optimize the dispatch and the market of electricity and natural gas, to be able to simulate multiple random scenarios that may be faced in the future. The high power results are synthetic series, for the entire planning horizon, dispatch of production units and spot prices. High ESOFIN, a financial model, evaluates in detail all the income and operational expenses derived from the energy market. Based on this model, typical financial statements can be evaluated. Balance, income statement, and cash flow. Finally, in mathematical models, financial risk management equations must be included to produce efficient risk versus income curves. From this process, decision makers have the necessary information to make a robust decision, according to their position with respect to risk. The first work carried out using this methodology dates back to 1998, when HY models were used for the planning of the exploitation of a natural gas field in South America. Smart grid optimization. Smart grids are the future of the electricity sector. Its impact is of immeasurable dimensions, considering the impact of the Internet. Smart metering measurement systems are the way to collect large volumes of information, big data, necessary to capture the added value of this new dimension. Demand has become an active agent, leaving aside the passive position it has maintained until now. The mathematical models used to optimize large power grids need to be revised considering this new environment. High SGO, Smart Grids Optimization, corresponds to a set of mathematical models aimed at supporting the decisions of the agents participating in smart grids. It is made up of the following models: optimization of demand response, optimization of electrical energy management in building complexes, such as universities, housing estates, shopping centers, etc. Optimization of energy efficiency, optimization of electrical energy management in industrial systems intensive in energy consumption. Projection of availability of renewable energy sources, short/medium-term prediction of the availability of renewable energy sources, such as wind, solar radiation and water resources. Load management optimization, electrical load management optimization. Phase balancing and voltage management. Distribution network planning, optimization of the design of smart grids of the operation, based on its reconfiguration. Electricity theft detection, electricity network fraud detection systems, and real-time optimization, advanced control systems for optimizing the operation of a smart grid. In 2014, IBM estimated that companies in the energy and utilities sector, which used big data and analytics, reported 23 times higher productivity than those that did not. Regulatory affairs modeling. HYPOTHALAMUS Artificial Intelligence, HY. Engineering projects for companies in the process of digital transformation. It presents its solutions and professional services based on decision-making artificial intelligence. Designed to optimize planning and operation in organizations in the electric and gas sector, using MOS mathematical models as a services. The advent of new energy sources, such as solar, wind, green and blue hydrogen. These sources are directly involved in the assessment of the impact on climate change and are usually associated with energy transition processes. Certainly, at the end of the production chain, new sources reduce CO2 and NOx emissions, a perception that can change if the entire cost of supply, including all the activities involved, is considered from the point of view of costs and emissions. Evaluating them accurately involves a greater effort in mathematical modeling. If the second aspect, the supply of electric batteries, is considered, the situation may be different. The battery production process involves the exploitation of special minerals, lithium, cobalt, zinc, magnesium. Its cost and emission of CO2 and NOx includes location, exploitation, transport and industrial refining. When the battery reaches the end of its useful life, its disposal is an issue that must be included, since it can include the development of specialized plants in this business. The cost of a battery for a car is high, and in many cases the relationship of the battery with the brand generates undesirable dependencies in a competitive market. These accounts should include accurately assessing the social, environmental, and economic sustainability of the project. It is possible that, when considering all accounts, including all the supply chains of all resources, the project is not profitable, and/or it is not environmentally sustainable, because it generates more pollution than it avoids. Electrical asset maintenance. Interconnected systems maintenance. Holistic planning is understood as the integrated planning of the largest installations of the electricity system. These can be power plants and/or generation units, energy storage, conduction channels, reservoirs, transmission lines, and transmission system substations. To analyze the above, a model can be generated that integrates the economic dispatch, or any subsequent modifications, with the maintenance model, equations that represent the maintenance process for each type of installation. The objective of the operation will be to maximize the social surplus, which for electricity systems in which an inelastic demand is assumed, corresponds to minimizing operating costs. Below are the results of a realistic example case. In these results it is possible to visualize the coordination of the maintenance of the largest generation plants of the interconnected system. Below are the results of a realistic case study. In these results, it is possible to visualize the coordination of the maintenance of the largest generation plants of the Colombian interconnected system. As a result of the optimization model, the figure shows the availability of the generation plants, for each period of the planning horizon. Electrical asset maintenance. Case: solar power plants. Energy availability and demand introduce many uncertainties into the operation of low-carbon power grids. One way to address these uncertainties in network operation is to develop an accurate forecasting algorithm. Topic areas in supply/demand modeling in solar farms include availability of renewable sources, e.g., wind and solar, demand forecasting and demand pooling, and rule of active ingredients, solar cell groups. It should be borne in mind that all these issues are part of the problem and that, if all of them are not solved, the decisions taken do not have to be optimal and can lead to undesirable consequences. Below is an example of how AI can be leveraged to solve PV prediction tasks following the model proposed by Yang et al. To predict solar irradiance on a farm during the K+1 period. An example is referenced where AI can be leveraged to solve tasks such as photovoltaic prediction, following the model proposed by Yang et al. To predict solar irradiance on a farm during the period K+X, and allocation of maintenance resources, using a mathematical optimization model. The figure shows the geographic locations of the target solar farm, C6, and N neighboring solar farms. The result is a scheduling of resources to attend to maintenance work, in all solar plants, during the planning period or during a fixed cycle of maintenance activities. Software factory for the electricity sector. Software production is at the heart of a highly complex mathematical modeling activity. To facilitate this process, HY offers several alternatives. The production of enterprise-wide optimization systems, EWOS, based on the integration of prediction models with optimization models, has been a difficult challenge to meet in most industrial and social organizations. This has led to a fall in potential productivity, which translates into higher costs, of all kinds, economic, environmental and social, to achieve a certain standard of living. HY offers its software factory, to implement complex mathematical models as part of EWOS. To do this, the interested party sends the technical document with the algebraic formulation and a test database, and HY sends them, in days, the result of the requested service, which includes basic user interface, technology transfer, linking to SQL databases, all commercial rights, information system data model, algebraic documentation, MS Word, source code in multiple optimization technologies, and mathematical models including large-scale optimization methodologies. The development time of a model, and its environment, depends on the original information provided by the client and the number of mathematical elements, sets, parameters, variables, and equations contained in the model. A standard model of 10 generic equations can be ready in 1 or 2 weeks. Testing the model requires a database that the customer must provide. To visualize the quality of the work, the interested professional can download an example of GAMS produced by Optex. In this way, any company in the electricity sector can have the high-quality software it requires to maximize its productivity and competitiveness. As George Bernard Shaw would say, imagination is the beginning of creation. You imagine what you desire, you will what you imagine, and at last you create what you will. Thank you very much for your attention.